still going to be the same even after obfuscation. So I wrote classes that would basically create a signature for the JavaScript functions. This is an example of one of the signatures in the data files for RigWit. You know, it's base 64 encoded. At the bottom here, this is the actual signature. So you can see, actually, let me get the laser pointer here quick. You can see that some variables are being defined here, but instead of using the name that was in JavaScript from GWT, it's been replaced with a generic name, so var11 or object 13, member 14, so that no matter how it's presented to RigWit, the same signature is going to be generated because the variable names are generated in a predictable manner. Effectively, it's not quite sequential, but it's still predictable. The second part of the signature are the field names, or the symbol names. They're only recorded once. You see class is here twice. That's actually because there's two different symbols named class within this function. So that when RigWit goes back through and discovers a match for the signature, it can restore everything to the format that it was before. Let's see, the other, oh, sorry, hang on just a second here. And I forgot to include a slide for what it looks like after it's deobfuscated, but you'll see that in a minute. This is one of the callbacks that's used for RPC. So this is essentially the JavaScript that's responsible for sending it. Completely unreadable, of course. I put the wrong slide. Well, okay, sorry about that. You'll see a little bit more detail in just a minute. So the demo is not really a demo of RigWit per se. It's actually pretty boring to watch. You just you give it the HTML file, either from the command line or in a GUI. You hit enter or click OK, and it gives you back something else. So it also takes a while to run because not a huge amount of time, but about a minute, and just a minute delay while waiting for a tool to finish is not very interesting. So instead, what I'm going to show is just the output of it, and the live demonstration is going to be the sort of a walkthrough of pen testing a GWT app. Now, this is a real app that we're going to use. Matt set up the Matt set up the virtual machine for it. It's OpenKM, which is essentially an open source document management tool. So we're going to basically just run it through Burp, and I'll show you what everything looks like. Now, OpenKM is well written. I didn't do a full pen test against it, but it avoids a lot of the vulnerabilities that we see in more poorly written GWT applications. If you log in, wait a minute, of course. This is why you don't see more live demos at cons. All right, so it looks pretty nice. It's slick interface once everything comes up, which who knows why it's not. Again, not Matt's fault. Here we go. Okay, it was just taking a minute for all the images to load. So it's really a pretty slick interface. You have a menu. You have something that could easily have been written for a desktop. It's going through some initialization after we logged in. So let's go over and take a look at exactly what was being requested through the proxy. Here's the login. Now, this is not a login through GWT. This is just a traditional form that's being submitted. There's no reason that you can't send logins through GWT. It's possible to do securely, but this is a common place where GWT apps will mess up, because really the login should be its own application. As soon as you started using a GWT app, you get all kinds of information about the classes and the RPC calls that can be made without having to log in. And while, in theory, if you have everything secure, that shouldn't be a problem, in reality, it gives a much larger attack surface to unauthenticated attackers, that don't have credentials. So basically the OpenKM developers decided that they were just going to not bother with that. Just create a simple page that for logins. So it starts going through, stuff that you would see with most applications. Get some JavaScript, some style sheets. This JavaScript is just responsible for redirecting to the correct JavaScript based on the browser type. So you can see that there's a lot of different names in here. Well, you might not be able to see. It's a little bit small. But the big piece is right here. And it's huge. Burp won't display it. Won't fit. So let's go back to our browser. And I just bookmarked the file. You can request it directly. And the main thing that you want to look for is a string of hexadecimal characters followed by .cache.html. And it doesn't display anything. You open it up. Open it up. There we go. All right. Well, suffice to say that it's huge. So huge that it's taking a while to load. Man, I must have really done something bad in the speaker's room. Anyway, it's huge. You saw samples of it earlier. So instead of looking at it, we can just go back and we'll pretend that we ran it through regwet, waited a minute or two while all the deobfuscation runs, and we'll just look directly at the output. Hold on. In just a minute, I'm going to turn the speaker, the microphone off and start cursing. There we go. No, that's not what I want. Okay. Let's try this again. All right. So, here we go. This is what Rigwit will generate. First thing that it lists are all of the RPC calls that can be made and the class that they sit in. So this is for the authorization service, which isn't actually for, it doesn't handle authentication, it just handles user management essentially. It lists the parameters that are required for each of the calls. There's no way of knowing what the parameter name is, which is one of the challenges that still exists even after Rigwit. There's no way of getting it back. That's something that's completely stripped out of the file. So in order to figure that out, you basically have to start interacting with the application, watch what data is sent when this RPC call is made, or if you never see it, if it's never called directly, because of privileges or whatever, you can still generate a request, and we'll talk about that in a minute. The next thing that it shows are all of the other classes that are client side. And the fields and the methods, some of them can be deobfuscated depending on how much data is removed, some of them not. You can click on the link to the function. All of the functions are basically hot links so that you can jump between them. And then if you have the code, which is more nicely formatted. We'll just jump down here. More nicely formatted, has a syntax highlighting and so on. So let's go back to Burp and take a look at some of the calls that were being made. You can see that after it loads that large file, it mostly just requests graphics, never really needs to get any more HTML from the server. And eventually it starts getting into the posts, which is where it's actually making RPC calls. This is the format for GWT RPC. It's not all that intuitive, even though it is a little bit. So let's go back to the slideshow real quick, and I'll sort of walk through the format of how the RPC is set up. Okay, here we go. So the first field, all the fields are separated by pipes, which is pretty obvious. The first one is how many parameters are being sent to the server. I'm not sure actually what the 0 is. I think it's a version, but I'm not positive. 6 has to do with how many strings are here. One of the things that Google did in order to decrease the size of the transfer was to set up a string table so that if you were referencing the same string multiple times, it was only defined once. So there's 6 strings. Starts off with just with the URL that it's being sent to, the URL of the RPC service. Has a hash code, which my mind is blank as by what exactly that does. Class that's being called, the method name that's being called, which obviously these two are pretty important. The next strings have to do with the parameters that are sent to this method, which are, it's a array list. So this is the content of the array, just Java string, and this is the data for it, okmroot. The rest of it are the actual parameters. So parameter 1 matches up, or the first parameter matches up with string number 1, the second with string number 2, and so on. The very last one is the array, has one element, which is what the 1 is for. 5 represents the type of data that's stored within the array, and 6 represents the final string, okmroot, which is the data that was being passed. So let's go back to VM real quick. And what we can do is we'll just grab this one here, and I can kind of show how the some of the attacks work against this. Let's see. All right, so one of the common things that we see with vulnerable GWT apps is that they don't have any kind of authentication enforcement. It's easy enough to test for. Basically, just kill the cookie, send it, and this is what you should get back is a some sort of error, which just depends on the exactly how they've implemented it. But call failed. All right, so we can go back. Something else that can show is what happens with a. Oh, no, there's not the right one. Back here. All right, so let's take a look at this class, the OKM repository, and you can go to the top first. Come on. There we go. All right, so these are the methods that are supported in that. Get root, I think, is what was being called. Yep. So we could change it if we wanted to sort of explore the application and see what else is there.